Hello everybody, I'm Abhijit. I'll be giving you a lectures on Elastic MapReduce, how it can be implemented in Amazon Web Services. So first of all, what we need to go is we need to log on to Amazon Web Services. Then we need to write EMR over here. Once we write EMR, it will take us to the Elastic MapReduce section. As you can see, a lot of terminated clusters are over here, which we of course, tried working with before we can make this video finally. And I click on clusters, and I give my cluster a name, that is AA. And I don't choose step executions, but rather I choose cluster, and I would choose core Hadoop and the latest versions of Elastic MapReduce. Now, Elastic MapReduce is basically an algorithms which consists of two parts: mapper algorithms and reduction algorithm, or the reducer algorithms. It's basically used to analyze big data. Now, big data is a kind of data which comes up with a lot of issues, uh, and coping up those issues, uh, that makes us all work with Hadoop, because Hadoop copes with all these issues which we normally face with big data. These are volume of the big data, variety of the big data, velocity of the big data, and veracity of that big data. So we click on core Hadoop, and then instance type is m3.xlarge, which is quite large with respect to T2 micro. We'll choose one instance. If we would have chosen three, in that case, one would have been a master node, and the rest of the two core nodes would have been slave nodes. So we are going for one node. We'll select a pair, and the key pair name is Sydney, because we are working in the Sydney data center of AWS. And we'll straight away go to the button. It says create cluster, and it would take about 3 to 4 minutes for the cluster to get created. And once you create the cluster over here, I mean, a large cluster gets created at the EC2 section. Okay, now we see, click on running clusters. We see it's initializing. So let's see whether it can be connected or not. Yes, it can be connected. I copy down the IP address. This M3X large is basically that Elastic MapReduce cluster. Now I click on putty. Then I'll find the key. I'll find the key from here. Okay, Sydney.ppk. Now, ppk is private, putty private key. It has been converted to .ppk format from PEM, which is privacy enhanced mail format, which can be basically availed from AWS. Then we converted it to .ppk by means of using putty generator, because putty understands only .ppk format. Now we are logged in, and we will log in as Hadoop. Right, it's showing Elastic MapReduce, and we'll go to root. Now we'll create a directory under root. We'll give it a name repos. This will put all our required files like mapper.python and um, reduce.python and all other required files to run the Elastic MapReduce program under that particular directory. We'll go and see whether it takes any update or not. It says that another lock is actually holding the yum lock. Yes, in fact, actually the instance is getting created. Instance has not, the EMR instance has not yet fully been launched. So let's see. Yes, it's still starting. Okay. So once. This is the previous one, so don't worry about that. Again, type the command. Yes, this time it will work. Now, after having the update, I will install Samba such that I can put all my required files to run the AMR program inside this cluster from my Windows laptop. And let's see what's the condition. Where is that repos? Let me figure it out. Yes, repos is there. Let me make it universal. Pause. Okay. Now I would assembly. Let's see what's the name of the package. Okay. Then what I'm going to do, okay, now I would validate the users. I'm just configuring the Samba. I've gone inside that assembly.conf. Valid users. We'll make it Hadoop. Okay. Path. I will give repos. Read only. No. Okay, now I have configured that smb.conf. Now I have to provide a password for the new user Hadoop of the system, of the EMR system, EMR cluster. One extra S is there. Okay, not having user Hadoop. Yes, I'm changing the password for Hadoop. I will give a simple password this time for demonstration purpose. And I'll create user and password for Samba as well. Now the Samba user has to be a user of the system, correct? Okay, now let's see the IP of this system. Let's see the IP of the systems and we'll move on over here. Okay, it's not showing up, so let us do something else. Service start. Okay, now it will work. Let's see. Somebody. Let's see the now it will open. It will say password. I'll give it Hadoop and I'll give the password. We'll put our stuffs inside that repos directory. These are the kind of stuffs which are there inside. I would just like to copy EMR. It would get copied. It would just take a minute or so. So it would take one more minute to get copied. And these are the kind of commands which we would be using. Okay. These are the kind of commands which we be using. So let's see. We pause. Okay. Now I will copy all the content of EMR and I'll cut it and then I'll paste it again in repos. And after that I shall delete EMR directory. Okay. So let's see how it gets copied. It will take a little time because Sydney is so far away from Kolkata, from where actually I'm showing you all this video. As you can see that we are having both the mapper and the reducer.python file. Just some sex left. After some seconds, it's a matter of seconds. Okay. Now we will delete this EMR. Now let me tell you one thing. Or here the input file is basically this one. It take a little while to get populated. It's basically a story. So would be our input file. Mm, this would be our mapping file, mapper.py. This would be our mapper.py file. Don't worry, I'll give all these things to you. And this would be this is basically our reducer file. Okay, and this is basically the Hadoop streaming.jar file. Now let me move on to Putty and play with the commands. So we'll see that repos is having a lot of things, and mm, uh, we will convert that sinbath.txt into input.txt. Just cp override, yes, done. Then we'll do our next course of action. We'll put that input.txt file into Hadoop file system. Okay. Then we will use our input.txt. We'll map it using our mapper.pythons, and then we will sort, and finally we will reduce it, and we'll put the output inside output.txt. Let's see how it works. Okay, now if you can see the content of input txt, that's a story. Okay, now I'll show you the output. So let's use vim. Okay. Vim dot txt. So A is used 208 times, capital A 12 times. Now our MapReduce algorithm has worked pretty fine. This is what we intended to do, and we got our result. The two Python program worked absolutely fine. So I'll quit, and then we shall use the Hadoop command right now. Put it over here. So it's running the Hadoop stuff. In fact, so it's getting reduced, it's getting mapped. Okay, let me see. Yes, 75% reduced. Okay. Let me see that. Let me show you the command which I've used. Hadoop jar, then user slash library Hadoop MapReduce. So MapReduce Hadoop streaming.jar we have used. Then we have used the mapper.py and reducer.py Python program. Input as input.txt and output as opp.txt, things like that. Let's see, running the command once again, p1.txt. It would take a little time for the MapReduce algorithm to work along with Hadoop. %75 mapping has been done. And within a short while, we will get the output. Yes, we got wreckage 1. You 4 times the word you have been used. voice has been used 2 times. It's actually a story of Sinbad, terror stricken used 1 time, terrible 2 times, terrifying 2 times. So in that way, we conclude our session, and in this way, we showed that how elastic MapReduce algorithm can be run inside a Hadoop cluster inside Amazon EMR, Amazon Web Services Elastic MapReduce module. Thank you. Now we'll just hold after that. Since these things are paid, these things they do not come for free, so you have to immediately terminate your instance once you once your work is done. So that's what I'm doing. This was my instance terminating user request. Okay, thank you very much.